So hello everyone, thank you for joining us. And this is our project called F-COMCEH-23-B. So my name is Mirim and I'm responsible for Java code.
My name is Camila and I'm responsible for SQL queries and data in page admin.
My name is Selima and I'm responsible for database connection.
So our project is examination system, and this application provides a simple way for students to take exam, see the results, and log in and register students. The purpose of this project is an easy way for students take exam. The features of this project is you can log in or register. You can choose any subjects, you can choose any test, and at the end of see the results, and you can see all the results of test you take. So let me demonstrate the project, how it's work. And the first you register and you click the register and write your name. Then you write your name and you click login, and you see and now you see the message that your registration is successful. So then you click all lessons and you will see subjects. You can choose example, I'll choose math and I'll take an algebra test. So you answer the questions and now you will see your results and you click OK, and now you can see all the results is what this our all results is taken, and this how is our project is working.
Let's talk about utils. We have 3 utility classes. First one, what we have is database initializer. This class ensures the database schema is correctly set up. It creates 5 tables if they don't already exist. First one is users. Example, a user might be ID 1 and username John Doe. This is users table. Second one is subjects table. Defines the subjects like math or science. Third one is tests table. This one links subjects to test names, for example, algebra for math. Third one is questions table. There are contains test questions and their correct answers. And the last one is result tables. Records user scores, linking them to specific tests and users. Each table uses primary keys to uniquely identify records. And at the end of the process, the code prints a success message confirming that the tables were created or already exists. This one. The second class is database seeding. The database seeder class preloads the database with initial data, enabling us to test the system without manual data entry. First one is subjects, add 2 subjects, math, and second one is science. There are also string insert tests, add categories like algebra, calculus for math, and physics for science, also chemistry. Third one is insert questions. Insert sample questions for each test with correct answers. This is our examples. And at the end of the step, a message confirms that the database has been successfully seeded.
What is a data access object in this project? Our classes act like a bridge between the application is the part of the system that handles logic and user interactions. The database is the part where data is stored and managed. Each DAO class is responsible for managing data for a specific entity. The purpose of user DAO. It manages user-related database operations such as registering users, authenticating users during login. For example, find by username method retrieves a user based on their usernames for logging validation. Subject DAO fetch and manages subjects like math and science. And then, for example, find all method retrieves a list of all subjects which is displayed to the user when they choose a test category. And then test DAO. It manages test related operations such as listing all tests under a specific subject. For example, find all by subject ID method. It retrieves tests for a given subject, such as an algebra test under the math category. And then question DAO. It handles questions for a specific test, allowing the system to fetch questions for a selected test. For example, find all by test ID method retrieves all questions linked to a particular test ID, ensuring that each test displays the appropriate questions. And then result DAO. It manages storage and retrieval of a test result, such as saving scores after a test completed, retrieving a student's test history or performance. The save method inserts a new result into the database, storing details like user ID and test ID, scores, and submission time. Why DAO is important? In this project, DAO classes keep database logic separate from the application logic, making the code easier, maintain, and extend. Each DAO class focuses on a single entity, like a user, subject, or test, which makes the system modular and easier to debug. DAO methods use prepared statements, which prevent SQL injections and ensure secure database interactions. DAO methods like find by username or find by test ID allow the application to dynamically fetch and manipulate the data depending on user input or system requirements. Designed to reflect the requirements in an examination management system, it includes the core entities needed to manage users, subjects, tests, questions, and results. The relationships between these entities was established based on logical association observed in the system functionality. To visualize the database structure, here's the entity relationship diagram. And user table represents user in the system. ID is a unique identifier for each user. Username is name or login ID for the user. A user can take multiple tests, which links to the result table. One-to-many relationships. Subject table represents subjects or categories like math or science. ID and name. Here's the name of that subject. A subject can have multiple tests. one-to-many relationship with the test. And then test table represents exams linked to a subject ID, subject ID, and subject ID is a foreign key linking to the test to the subject table. Name of the test, for example, algebra and science. Each test can have multiple questions, one-to-many relationship with the questions. And then question table, it represents question in a specific test. ID, test ID. Test ID is a foreign key linking to the questions to a specific test. Question text, it's a text of the questions. Correct answer stores the correct answer for the questions. Each test can have multiple questions, one-to-many relationship with the test. And then results table stores the test scores and performance for each user. User ID, test ID, score stores the score obtained in the test. Username and test name. Test name is denormalized attribute storing the test name. Result table links user and test to record results many to one relationship with the users and tests. Normalization. We performed normalization to ensure that integrity, reduce redundancy, and optimize the database structure. First, normal form. Ensure that each column had automatic values. Now I will show the example. Ensure each column and column had automatic values. For example, each question in the questions table is stored in the separate rows. Second, normal form, remove partial dependencies. In the result table, scores depends on the composite key, like an user and test ID. Third, normal form, remove transitive dependencies. For example, username and test name. Username and test name are stored in the users and test names tables respectively. Trades off and denormalization. We denormalized users and test names in the result table to improve performance for report queries. It's reduced the need for joins, making results retrieval faster. And then for the summary, we applied up third normal form for efficiency and selectively denormalized for better performance, balancing data integrity and speed.
So there are some examples of our queries. The first one, this SQL query retrieves all records from the result table, combining it with data from the users table to display user information along with their results. This query uses a join to connect the result table to the users table based on the user ID. It ensures that only records with matching user IDs are displayed, providing a complete picture of test results alongside user details. Second example, to find the total number of tests a user has done. This SQL query calculates the total number of tests each user has completed by counting the test ID in the results table for each user.
So, error handling. Error handling is a try and catch block. The try block is where you put the code that might cause an error, like connecting database or running the SQL queries. So if there are no errors, and the try block is running normally, but if it's an error, it stop the running the try block and goes to the catch block. So the catch block is handle the error. In our project, you will see the print stack trace. It shows the details of an error in the console. It's helpful for fixing the bug, and it shows what went wrong and what happened. So why is useful use try and catch block? So it's no crashing, and the program doesn't stop working because of error. You can see the error and you can fix it, and it's a database connection are handled safely. So the question is, how do you ensure the database remains consistent despite potential errors? So we use rules in our database to avoid a bad data, and so we use a foreign key, so ensures that when you are get a score and that the user is existing. So we have primary keys, so make sure there are no duplicates entires, and so we use backups. If something really went wrong, and we have a copy of our data. So how do you validate user input in your application? So in username field, you cannot let empty space, so it's give you error, and if the user is not registered, so it's also give you error. So we have creating a new user is registered, and it's perform a role of creating.
How did the team decide on task distribution? We divided the tasks based on our skills and strength. Miriam worked on the main Java application, creating the user interface and handling login, test selection, and scoring. I designed and managed the database, including creating tables and writing SQL queries. Selima connected the Java application to the database using JDBS and created DAO classes for handling data. We decided this way because each of us felt confident about our parts, and it made the workflow smoother. Was there any overlapping work, and how did we manage it? Sure, yes, there was some overlapping, especially when database integration. Selima was working on database connections, while Miriam needed those connections for the Java applications. Also, we have debugging. All of us work together to fix errors in queries and connections. How we manage it? We had regular team meetings to discuss progress and issues, used version control tools like Git to avoid rewriting each other's work, and also shared clear documentation so everyone understood the database structure and code. By working together and communicating well, we avoided big problems and completed the project efficiently. What about team challenges? Uh, Scheduling conflicts. Since team members had different schedules, it was challenging to find a common time for meetings and discussions. About communication gaps, at times miscommunication about task priorities or dependencies caused some work to be delayed or misaligned. For example, Selima required a finalized database schema for integration, but Miriam was still making adjustments. How were conflicts or disagreements resolved? First one is regular meetings, also clear documentation, task tracking, and mutual understanding.
So, the most challenging part for me was the error handling and making sure that data stays correct while we perform the multiple database operation and especially when the tables are connected and are connected each other, and especially challenging part was in results connect users and tests. So if I have more time, I would add more error exception like try and catch. So I'll make for teacher role and to like the teacher can see all the results. Teacher can create a task, can track test, can create a subject, and so like a student cannot see all the results and the student can see only his results, but the teacher can see all the results, and it will I will be improve in the future it.
Project impact. This project mirrors how modern educational institutions manage their exams effectively using technology. It applies directly to real world scenarios such as online examination platforms, remote learning systems, like supporting exams during the remote educations, during the COVID-19 lockdowns. Um, by reducing manual work and errors, this system saves time for teachers and administrations. Through this project, we improved our understanding and gained hands-on experience in database management, uh, application development, and collaboration, working as a team, assigning roles, and integrating components effectively. And the new methods that we learn, uh, we applied normalization up to a third normal form for data integrity, um, balanced performance with selective denormalization, and the project enhanced technical skills, teamwork, and the real world software development experience.
Thank you for your attention.